Okay, so we start here with linear equations into variables. It says slope and three forms of the equation of a line. It's what we're going to look at this section. So first, what is the definition of slope of a line? Well, it's the ratio of the vertical change to the horizontal change. Written, and so what they're going to write here is the slope formula. M equals y2 minus y1 over x2 minus x1. Okay, sometimes this can be written as the change in y over the change in x, which we abbreviate to be delta y over delta x. That means the same thing. Change in y over change in x is just delta y over delta x. It says, recall that a variable is a value that can vary or change. Variables are usually represented by x, y, z, and n. The value of a constant does not change. So here are some next synonyms for slope. So whenever we have word problems, these are the kind of things that you could look for them talking about. We've got the pitch of a roof, the grade of a mountain road, the slant, the steepness, and the incline. Those can all be substituted in. Instead of telling you to find the slope, they could just talk about those things and you should know we're talking about slope. So first example, it tells me to find the slope of a line through the points 3, 4, and -2, -1. So first we're going to find the slope using the slope formula we just looked at. So if I were to use the slope formula, this is x1. Let me use a different color. This is x1, y1. This is x2, y2. Substituting in, I've got y2 minus y1 over x2 minus x1, which is -5 over -5, which is 1. Okay, so that's using the slope formula. Now, sometimes we may just have a graph. So what if this was graphed for us? So I went right 3, up 4. I plotted my first point at 3, 4. Then my next one is -2, -1 here. So they could give me a line going through those points. Make those points a little bit bigger. If I wanted to find the slope, I could just count how much did I rise over how much I ran. So I'm rising 1, 2, 3, 4, 5. Then I'm running 1, 2, 3, 4, 5. So, yep, absolutely. Okay, so looking here, we have a bunch of lines that have a y-intercept of 0, and we're just basically looking at the slopes of each one of these lines. So if I start with this line here, that line has a slope of +2, so you see how steep it is. This line is in the same direction, but it's not as steep, so it has a slope of 1. So as we decrease in numbers, we are decreasing the steepness of our line. Here's one that's even less steep, and its slope is even smaller at 1/2. Okay, my x-axis here is another line that is flat. So that is a slope of 0 because it's not rising, it's only running. And then when we start in this direction, we're decreasing now. So as we start to decrease, our slope is now negative. If I decrease more quickly, it is a larger negative number, right? So -1. And then -2 is the biggest decrease at a time.
What's the slope of a line that's on the y?
Undefined.
Okay, because it has a 0 on the bottom.
Mm-hmm. So as my x's increase, my y's also increase for positive slopes. I think about looking at a graph the way you read words. We should read graphs from left to right, and you need to get in the habit of that because it's going to become more important later in this semester and especially in the next semester when we start looking at trig. But I'm reading the graph from left to right. So as I look at the line from left to right, if the line is increasing, it's positive. If I read this from left to right and the line's going down, it's decreasing. So think about reading graphs like we read words from left to right. So if I had to draw a line with a positive slope, as I go from left to right, it's increasing. If I had to draw a line with a negative slope, as I go left to right, it is decreasing. If I needed a line with a slope of 0, then that has to be a horizontal line. Then if I needed a line whose slope is undefined, that is a vertical line. Okay, so our next ones are what I consider the special examples of lines, when you have horizontal lines and vertical lines. When I first started learning these, I would get them backwards all the time about what I should be drawing when. Hopefully by now you've got some system in place that helps you know whether it's horizontal or vertical if it didn't tell me right here. Okay, so for me, my system that I finally came up with that helped me get it correct every time, this says the y value must equal 3. So I would go on my graph to where y was 3 and I would put a point. So y is 3 here. Okay, then I would pick another point where y is also 3. So think about, right here's the point 1, 3. Well, the y value is 3 there. 2, 3, the y value is 3 there. And so that helped me get straight. Hey, y is equal to 3 everywhere along that line. So that should be a horizontal line for y equals 3. And then similarly for y equals negative 2, go on your graph to where your y value is negative 2, plot a point, then pick another point where the y value is negative 2, and that helped me see, hey, I am looking at a horizontal line through y equals negative 2. Okay, then here's the other kind of example. Now we're looking at x value being 3. So I'm going to go on my graph to where x is 3. So I go on my x-axis to 3 and I plot a point. So here's a point where x is 3. Now where's another point where x is 3? Well, right here's 3, 1, 3, 2, 3, negative 1. So that would be a vertical line where y is equal to 3. And then for x being equal to negative 2, I'm going to go left to negative 2, plot a point, pick some more points. So here we're going to continue with our special cases. So first it tells me to find the slope of a line passing through negative 3, 4, and 5, 4. So if I looked at this before I did anything and I see that my y values are not changing, then I know that it's my change in y is going to be 0, and then my change in x is going to be some number. Well, 0 over some number is always 0. So I know the slope of this line is 0. Okay, but if I didn't notice that and I plugged into the slope formula, y2 minus y1 over x2 minus x1, I should still get that 0 over 8, which I know is 0, is my slope. And then again, if I were to graph these points, negative 3 and 4, 5 and 4, what kind of line is that with a slope of 0? It's a horizontal line. Now, people always get these backwards. Remember, 0 in the numerator is fine. We can have nothing and divide it among 20 people, and that's easy to do. So 0 divided by some number is possible. But now the next example is the other direction. Notice here how my x's are not changing. So my y's, my change in y is going to be some number. My change in x is going to be 0. So now if I had 20 pieces of pizza and I divided among 0 people, how many slices does each person get? Well, you can't, huh?
No.
They get all of them.
Each person gets all of them?
There is no people.
Problem. You can't divide by 0. There's nothing to divide it amongst. So that's why we call that undefined, because it doesn't work. And again, what that looks like algebraically, if you were to plug into your formula, y2 minus y1 over x2 minus x1. So you see here you're going to get negative 4 over 0, which gives the undefined answer, because that can't be done. If I plot those points, negative 2, 3, and negative 2, negative 1, you see what kind of line I'm looking at? It is a vertical line, which has an undefined slope. So here we go again with the special cases for equation of a line. So it tells me to write the equation of a line passing through 2 points. And we're going to look at how to do that in just a second. But right now we're still looking at a special case. So my y value doesn't change. Right? It's 3 here and it's 3 here. That means the equation of the line would just be y is equal to 3. Any point on that line has to have a y value equal to 3 because it never changed. And then when you look here at the next example, line passing through, the equation of a line passing through negative 1, 4 and negative 1, 2, that time my x value never changed. So I know that my x value must be negative 1. And it can't be anything else. So again, if you were to graph these, negative 1, 4, negative 1, negative 2, that is going to be the vertical line where x equals a number. And then for y equals 3, we go to 2, 3, and we go to negative 5, 3. And that should be a horizontal line. Mine's not very good, but. So here are 3 forms that we can put our equations in. Okay, the first one is called standard form. That's when your x and your y are on the same side. So standard form looks like ax plus by equals c. X and y are on one side. The constant is on the other side. There are some rules about putting something in standard form. The first rule is a must be positive. Must be bigger than 0. The second rule is A, B, and C must be integers. So that means there can't be a fraction, a decimal, a radical. Okay, all those are wrong for it to be in standard form. So we have to make sure that we have both of those criteria satisfied. Criteria is not the word I was looking for. But both of those must be true in order for it to be in standard form. This is probably the least helpful form when it comes to graphing. Not a lot can be done there. But if I am given something in standard form and I'm told to graph it, I would most likely graph by finding intercepts, x-intercept and y-intercept. That's the easiest way to graph when it's in that form. Now the next form is slope-intercept form. That slope is very good at telling us 2 things. Do you know what 2 things it's good at telling us? Yeah, the slope and the y-intercept. Thus the name slope-intercept form. When it's in this form, the m represents the slope, the b represents the y-intercept. So if I'm in that form, I can identify those things very quickly. Or if I'm given those 2 things, it's easy to put it in this form. Now the next one, point-slope form, it's not as easy to graph. It's not terrible, but it's not as easy as slope-intercept form. But guess when this is more beneficial? When I know the slope and just a random point. Okay, I don't know the point is the y-intercept. It's just some random point. Then we would use this point-slope form. Y minus y1 equals m times x minus x1. And I'm just going to put this on here because people get this mixed up all the time. The y1, the m, and the x1, those will all become a number. the y and the x, let's use a different color. The y and the x, those are going to stay as variables. People will get in point slope form and they'll try to plug in just numbers all over the place, okay? And it's not right if you do it that way. The only place you're plugging in numbers are for the y1, the m, and the x1. Y and x, they stay as y and x. So now we're going to practice graphing. So both of these equations are in slope-intercept form. The y is by itself, y equals mx plus b. So first, starting with 3x minus 1. When we graph something in slope-intercept form, we always begin with the y-intercept. The y-intercept is negative 2, so on my y-axis, I'm going to go to, did I say negative 2? I'm losing it. My y-intercept is negative 1, so on my y-axis, I'm going to go to negative 1 and plot that point. Now we use the slope to find the next point. Now we always start at our y-intercept. So when I'm using the slope, I'm moving from here, from my y-intercept. Don't go back to the origin and move 3 and 1 from your previous point, your y-intercept, which is at negative 1. I'm going to rise 3, and I'm going to run 1, which should put me here at at 1 comma 2. Now all I need is 2 points. I can get more if I would like to, but all I need is 2. Through those 2 points, there exists exactly 1 line. So I'm going to connect those 2 points, and I have graphed the equation. Now some of you may have forgotten. Remember, if the slope is 3, we can write that as 3 over 1. So I have both a rise and a run, a change in y and a change in x. Okay, next one, y equals negative 2/3 x plus 4. Again, we're already in slope-intercept form, so that is good. So now I'm going to use my y-intercept to find a point. So on my y-axis, I will go to 4, and I will plot that point. Then using the slope, I will find the next point. So this time my slope is negative 2/3. Well, you've got options. You can either write that as negative 2 over 3, or you can write it as 2 over negative 3. What you can't do is write it as negative 2 over negative 3, because a negative over a negative is positive, and so that changes the slope. So for this, since I've already reached the top of my graph, I would like to go down with my next point. So I would like for my change in y to be negative. So I'm going to use this form of the slope. So I'm going to go down 2 and then to the right 3 to find the next point, which would be there. Then using 2 points, I can connect them, because through any 2 points there exists exactly 1 line. There is my line. Okay, so the directions here tell me to write the equation of this line in both point slope form and slope intercept form. So we will start with slope intercept form because it is what you are more familiar with. So to use slope intercept form, I need to know the slope and the y-intercept. Okay, so I would start with the y-intercept. It's easier to find. So where did this cross the y-axis? At negative 1. So I know my y-intercept is negative 1. Now we'll use the rise and run to find the slope of this line. So I'm going to go from this point to this one. So I'm going to rise 2. I'm going to run 3. So my slope is going to be 2 over 3. Now that I have my slope and my y-intercept, I can put this in slope-intercept form. Y equals mx plus b. And I'm now in slope-intercept form. Now next, if I were to put this in point-slope form, I need a point that's on my line and the slope of my line. Well, I know the slope, I just found it. It is 2/3. Now I would just need some point, which I'm going to call x1, y1. Okay, so I can pick any point on the line. There is no wrong point to pick. Okay, but to me, the y-intercept is a little boring to pick, so I'm going to pick one that's up here, a little more interesting. So my point is going to be 3, 1. Now, you could have picked this point way down here if you wanted to, -3, -3. Okay, you could pick some awful decimal that you can't tell what it is, right? That's why we don't want to pick the decimal points. But any point that's on the line works. Now, point-slope form is as follows: y minus y1 equals m, which is the slope, times x minus x1, which is 3. And so I'm finished. This is point-slope form. Okay, so that's all that you have to do. Now, just to show you that this is the same equation, what if I took this in point-slope form and put it in slope-intercept form? Have y'all done that before? Maybe. Y minus 1 equals 2/3 x. 2/3 times -3 is -2. I would move the -1 over. It would become positive. And so that would leave me with 2/3 x. -2 plus 1 is -1. So you see how it's the same equation, it points to the same line, it's just in a different form. One thing I need to mention, make sure when you're using this point-slope form, there are 2 built-in negatives to the formula. Y minus y1 equals m times x minus x1. So remember, the negatives built into the formula, that makes sure you change the sign of the value. Now let's do the same thing here. First, let's put this into slope-intercept form. So my y-intercept is where the line crosses the y-axis, which is 2. And then the slope of my line I can get by using the rise and run. So from here I'm going to go down. So down means I have a negative slope. So down 1, 2, 3. So I've went down 3, and then I went to the right 3. So that would be -3 over 3, which we simplify to just be -1. Now I know the slope and y-intercept, so I'm going to use slope-intercept form, which is y equals mx plus b. And you do not have to write the 1 because it's understood. So we would write it like this: y equals -x plus 2. Now if I had to use point-slope form, again I would use the slope, which is -1, and then pick some point. So the point I'm going to pick here is this point, which is at 3, -1. So again, putting this into point-slope form, that's y minus y1 equals m times x minus x1. I'm so dumb. Y minus y1 equals m times x minus x1. And so again, there's a built-in negative, and then I plugged in a negative. So minus a negative is positive, and then this built-in negative made the 3 become -3. Okay, so we're given 2 points, -2, 5, and -1, -3. And we're told to find the equation of this line and put it in all 3 forms: slope-intercept form, point-slope form, and standard form. So Okay, what form would I want to use? Well, slope-intercept form would be good if I had the slope and the y-intercept. I know neither one of these things. Next, point-slope form would be good for a point and the slope. I have points, but I don't know the slope yet. Standard form, you can't put it straight in standard form unless you have both intercepts, which I would rarely ever go straight to standard form. So for me, since I know 2 points and all I need is the slope, I'm going to put it in point-slope form. So first, to find the slope, we're going to need the slope formula. So the slope formula, y2 minus y1 over x2 minus x1, which simplifies to be negative 8 over positive 1, which is just negative 8. So now I know the slope and I know a point. I can pick either point I want. I'm going to pick the one that they're both negative. Okay, so into point-slope form, that's going to be y minus y1 equals m, which is negative 8, times x minus x1. So minus negative 1 is plus 1. So this will be my equation in point-slope form.
So it don't matter which point we pick?
No, it does not. So if you pick the other point, it would look like this. Y minus y1 equals m times x minus x1. But those are both correct. Okay, now I'm going to put these in slope-intercept form. So I'm going to look at the red one. If I had to put this in slope-intercept form, I'm going to distribute and get y by itself. So that's going to be y plus 3 equals negative 8x minus 8. You move the 3 over, it becomes negative, so that leaves me with y equals negative 8x minus 11. Now I've got it in slope-intercept form. Now just to show you, what if you would have picked the green one and you put it in slope-intercept form? Okay, well that's going to be y minus 5 equals negative 8x minus 16. That says y equals negative 8x minus 11. So no matter which point-slope form you pick, you get the same slope-intercept form because they point to the same line. So once you simplify it and put it in slope-intercept form, these two lines have the same slope and they have the same y-intercept. So we graph them the same way. Now if I got to put this in standard form, I need x and y on the same side, and I need the coefficient of the x to be positive. So I'm going to move the 8x over to the other side. It becomes positive 8x plus y equals negative 11. All of those are integers, and my a term is positive, and x and y are on the same side. So that is standard form. Fahrenheit temperature F is a linear function of Celsius temperature C. Two ordered pairs of this function are 0, 32 and 100, 212. What are those 2 points? What's this? What does that represent?
That's the freezing point.
Freezing point of what?
0 and 32 are both the freezing point of water.
Of what? Freezing point of what?
Of water.
Oh. So this is the freezing point of water?
Yep.
What about this?
It's the boiling point.
Boiling point. Oh. Huh. Interesting. Okay.
That doesn't really help us much, but
But that's how you get those points if you weren't given them. What if I told you to make the Fahrenheit and Celsius equation without any points? Those would be the 2 points I would use, because those are the 2 that I know for both. Use these points in the point-slope formula to write f as a function of c. So we know that our x values represent Celsius, right? That's the Celsius temperatures. The y values represent Fahrenheit. So, first thing I would do, I'm going to find the slope of my line. So y2 minus y1 over x2 minus x1. So 212 minus 32 is 180 over 100, which is 18 over 10, which is 9 over 5. So now this is where you got to make sure you keep everything straight. My y value is equal to Fahrenheit, right? And my x value is equal to Celsius. So when I'm plugging this into the point slope formula, it's going to be y minus. Okay, now which point do we want to use? I would use this one because it has a 0. That's going to be real nice. So y minus y1 equals m times x minus x1. Okay, but then let's substitute in because it tells me to write my function in terms of f and c. So instead of y, it should be f minus 32 equals 9/5 times c. And then you could put that c minus 0, but that really does nothing for me. So I would just simplify it like this. Then I'm going to go ahead and put this into slope-intercept form because it's really easy to. F equals 9/5 c plus 32. Now I have the function f isolated. And I think I needed to do that because it tells me to write f as a function of c. So that normally means we want f isolated. Okay, the next question. What is the Fahrenheit temperature when Celsius is 180? It's hotter than I care for it to be. Okay, so I know Celsius is 180, so I'm going to plug in 180 for C. So that's going to give me F equals 9/5 times 180 plus 32. So that's going to be 18 over 5. That's 36 times 9, 360 minus 36 is 324. 324 plus 32, 356. Is that right? Did you plug it in? Okay.
Yeah.
So the Fahrenheit temperature would be 356 degrees, which again is hotter than I care for it to be. Let me just go on the record by saying you really want to pay attention to this because people get this messed up backwards. They don't understand it. And this is a good segue to a lot of the math we're fixing to do the rest of this chapter. So make sure you're really thinking through it. You're taking notes. You're able to tell the difference between these things. So we're going to look at intervals where the function is increasing, where it's decreasing, and where it's constant on a function. So we're looking for where those things are happening. So again, we're going to look at this like a timeline, like we read. We want to read the graph from left to right. Okay, so let's first look. It tells me to state the domain and the range. Okay, so that's what we're going to do first. The domain is just the set of all x values that are used. So when I look at this graph, I'm going to start looking on the very left-hand side. So I see there's an arrow on the left, which tells me this graph is going to the left forever. So the smallest x value that the graph takes on is negative infinity. It can't go any more left than it currently does. Now, the next value is going to be the greatest x value. Well, this graph comes to a stop right here. It doesn't go any more to the right. So that means the greatest x value is 2. 2 is included because it's a filled in dot. So we put a brace around 2, or a bracket around 2, to show that it is included. So this would be my domain. Any questions about finding domain? Next, find the range. Okay, so the range is going to be, again, the smallest possible y value. So this time I'm looking from bottom to top. So again, this graph has an arrow. It's going down infinitely. So the smallest y value is negative infinity. Now we're going to look for the greatest y value. So it's capped off right here. It never goes above this line. So the greatest y value is positive 3. And again, it's included because it actually does reach 3. Any questions about domain and range on that one? So I'm gonna keep the same message. I'm gonna do all 4 of them domain and range first. So let's look at this one. Okay, so again, looking for the domain, that is the possible x values. So I'm starting looking at the left. How far left does this graph go? Well, it's got an arrow, which means it's going to continue in the left direction forever. So the lowest x value is negative infinity. It's never going to stop decreasing. Now let's look at the greatest x value. So I'm going in this direction. Again, I get the arrow. So that means it's going to the right forever. So the highest x value is positive infinity. Another way we could say that is all real numbers. Okay, our x's never take a break. Every x value has a corresponding y value. Next, we're going to look at the range. So the range is the list of y values. So we start at the lowest possible y value. So does the graph enter this area? No, it never gets down here. So that means there is a lowest y value. And it reaches that lowest y value right here. So the lowest y value would be at negative 2. And that's included. So I put a brace or bracket. I don't know why I call them braces. Now, looking at the highest y value. So again, I have the arrow, which means it's going to continue in this direction infinitely. So since the graph is going up forever, its highest y value would be positive infinity. Any questions there, domain and range? Okay, looking at the third one here. So first, my domain, the lowest possible x value. So does the graph go towards the left forever? No, it doesn't. It comes to a stop right there, which means the lowest x value occurs at negative 3. Now the highest x value, again, it does not go to the right forever. It comes to a stop right there. So the highest y value is positive 5. Both of these are included, so we put them in brackets. Next, looking at the range. So what is the lowest y value the graph takes on? Well, that happens right here, and it has a y value of 2. So the lowest value of the range is 2. Now we want to look for the highest value of the range. Okay, that occurs right there. The graph never gets any higher than that. So 6 is the greatest y value. Okay, then the last one here. Look at the domain, that's the list of x values. So when I look at the left, okay, the graph never stops. It has an arrow that it's continuing in that direction. So even though it's not heading left very quickly, forever it will be heading in the left direction. So the lowest possible x value is negative infinity. It continues to the left forever. Similarly, heading towards the right. Okay, the graph is not heading right in a hurry, but it is gradually moving right infinitely. So the highest x value is positive infinity. Next, we'll look at the range. So the range is the list of y values. So does this graph have a lowest value it reaches? Yes, it never goes any lower than that position right there. So that means the lowest y value, the lower boundary, is at -4. Again, it's included, so I put a bracket. Now I'm looking for the highest y value. So while the graph stops there, it has arrows, which means it's continuing in that direction infinitely. So it never reaches a high point, so it's positive infinity. And again, that would be a parenthesis. Okay, the next thing we're going to look at is we have to tell where our graph is increasing, where it's decreasing, and where it's constant. So increase, decrease, constant.
Wait, before you do that,
Thank you. So first, we want to identify where's the graph increasing. So again, we're going to read the graph from left to right. If the graph is going up, it's increasing. If the graph is going down, it's decreasing. And if the graph is staying steady at one value, it's constant. So as we start looking at this graph from the leftmost point, as soon as I enter into the picture, again, you're walking like it's a timeline. Here you are on the axis, walking along. That's the way I picture myself every time. So as I come up onto the graph here, it's already increasing. So it starts off at the very beginning increasing because it's going up. So the leftmost point where the graph is increasing is negative infinity. When our first x value we can think of, the graph is increasing. And it continues to increase until, when did we stop increasing? At -2. It's not 3. It's not y values. You're telling where you're at. You're walking along the graph. So it stops increasing when you're at -2. The graph steadies off. So we would say it stops increasing at -2. Then what happens? Well, at -2 you're walking, and it is now constant. When does it stop being constant? When I'm at +2. It stops being constant there. So it is decreasing from -2 to +2.
Wait, how? How it is constant?
It's constant from -2 to +2. Yeah, my fault. And then the graph stops. It never nothing happens after 2. That's the end of my graph. So it is never decreasing. From the moment the graph starts, it's increasing until it gets to -2. And then it is a constant from -2 to 2, and then the graph is over.
wait, so like basically when the line kind of goes flat is when it's like decreasing or increasing?
So now here's our next one. So again, remember, you're walking along the x-axis. So when you first happen upon this graph, what is the graph doing? Is it increasing, decreasing, or constant? It is decreasing. From the moment we start, the graph is decreasing. So I know it is decreasing at negative infinity. Up until, when does it stop decreasing? When I reach negative 2. At negative 2, it's no longer decreasing, it is staying the same. So from negative infinity to negative 2, the graph is decreasing. Okay, then what happens? At 2, I'm walking along and it's staying the same distance away from me, right? So it's being constant. And when does it stop being constant? When I get to positive 2. So the graph is constant from negative 2 to positive 2. And then the graph starts to increase. And when does it stop increasing? It doesn't. It never stops increasing. It's continuing to go up forever. So the graph is increasing from positive 2 to positive infinity. Okay, here's the next one. Increasing, decreasing, constant. So as I happen upon this graph, what's happening at negative infinity? As I first walk up on the graph? Nothing. The graph doesn't exist. So when does the graph start existing? At negative 3. And what's happening when I get to it at negative 3? We're increasing. So at negative 3, the graph is increasing. When does it stop increasing? When I get to 1. Okay, then what happens after I'm at 1? Starts decreasing until when? 5. So we're decreasing from 1 to 5. And then the graph is over. So it is never constant. It's decreasing from negative 3 to 1 and increasing from 1 to 5. So when I happen upon this graph at the very beginning, what is happening? Okay, we can't see it, but we talked about it before. This graph is going in that direction forever. So when I first come to the graph, it is doing what? It's decreasing. And when does it stop decreasing? When I get to 0, the graph finally stops decreasing. Because we always are walking along the x-axis. It's your position as you're walking along. So it stops increasing at 0. It starts decreasing at 0. So from negative infinity to 0, the graph is decreasing. And then the graph starts to increase from 0 to infinity. It's never constant. Okay, so we look at this relation. So you see I've got ordered pairs, 4, 7, 5, 8, and 6, 9. Every time you see the number 4, it's beside 7. Every time you see 5, it maps to 8. Every time you see 6, it maps to 9. Each input, each button always gives the same output. 4 always gives 7. 5 always gives 8. 6 always gives 9. They're consistent. That makes this a function because each input, each value in the domain maps to exactly one thing in the range. So that makes it a function. Okay, we look at this one. M maps to 1, T maps to 1, H maps to A.
Yep.
Okay, so every time you see M, it's next to 1. Every time you see T, it's next to 1. Every time you see H, it's next to A. So each value in the input goes to only one value in the output. So this would also be a function. Hello? No, I'm not. All right. Uh-huh. Yeah, thanks, you too.
And it's still recording.
Okay. This is also a function. So this is like the vending machine that has two Coke buttons. It's like the second one. Every time you press this button, it gives one. When you press this button, it gives one. But it's always the same thing when you press it. M gives one, T gives one. H gives A, well, that's kind of random, but it's consistent. So that's a function.
But so don't have to have the same number on, like the same number of numbers on each side?
No. Okay, look at the next one. We've got W maps to 4. C maps to 4 and 2. So sometimes when you press C, you get 4. Sometimes when you press C, you get 2. Well, that's not what we want. So this is not a function. It is a relation, but it's not a function. Okay, this is kind of the outlying case. You won't see this, maybe past this example. You see how you get 3 elements in your domain, but only 2 of them map to things. You've got a leftover 5 that has nothing that it goes with. So this would not be a relation. So we don't even talk about this. Okay? So that's the difference between functions and not functions.
Wait, so if you just have a leftover number, it's not a function?
This?
Like if we don't have
This is not even a relation. So I can't even talk about it in terms of a function.
Oh, wow.
Because this 5 has nothing it's mapped to.
It's like if you had a button that just does nothing.
Yeah,
It does
no.
nothing every time, is it?
No. A relation is a set of ordered pairs. So here are your ordered pairs. 2 maps to 7, 3 maps to 11, and 5. It's not a set of ordered pairs. You can't even talk about it in terms of a relation.